Okay, so let's go find what A complement and B complement are. I'll just draw them down here, and then we'll take the union, which means or. So A complement will be, there's -3 and back, and here's 0 and out. And then B complement, I'm just going to draw it down here underneath it. So it'll start from 1 and go back, and then up to, that's supposed to be an open hole up here at 4, right? So then it's closed 4 and out. Okay, so if it's an A complement or B complement, let's see, I'm losing this, I'm getting all the way up to 0. 0 is not included in either of them, so I've got x's are less than 0, so x's in the reals, x's are less than 0, or then I've got all of this out here, and then I pick up this, so it can be up to here, that contains that, and so our x's are bigger than 0. So it's all x's except 0. All right, so A complement intersect B complement, what's in common? So I see I've got the x's that are in the reals, such that x's are less than -3, and then I've also got between 0 and 1, or between 0 and 1, or, move that out of the way, or if I've got B complement, that means the x's are bigger than or equal to 4. Hey, these two are the same. So it's really De Morgan's law in practice here. To take A union B complement, it's the same thing as saying A complement intersect B complement. All right, let's finish these off. Are the positive integers a subset of the rationals? Yes, they are. Are the negative real numbers a subset of the rationals? No. If I take the union of the positive and the negative integers, does that give me all the integers? No, because 0 is not positive or negative. And if I take the intersection of the rationals and the reals, it gives me the rationals. Yes. All right. So now we're going to talk about a partition. So this mutually disjoint idea means if I have all of these sets that are separate and the whole set is the union of each of them. So that's this picture up here, right? So if the whole set A was this whole thing, and I had mutually disjoint sets that gave me all of it, that's a partition of A. All right, so if I call E the even integers and O the odd integers, is this set E and O a partition of the integers? Yes, it is, because we know 0 is even because it can be written as 2 times 0. If I take T as the set of positive integers and R the set of negative integers, does this give me a partition of the integers? No, because 0 is not positive or negative. All right, so now we're moving on to power sets. So what's a power set? Power set is the sets of all subsets. So I'm going to find the power set. So it's going to be a set of sets. So the sets that I can make out of this set from A, I could make a set that contains the number 1. I could make a set that contains the number 2. I can make a set that contains both of them, or I could use the null set. So we've got 4 elements in my power set A, and how we write that is like a script P. So when I have 2 elements, I'm going to have 2 to the squared elements in my power set. So if I have 3 elements, I'll have 2 to the third elements in my power set. All right, so we talk about 2 tuples, which are just ordered pairs, right, where the A and the C are the same and the B and the D are the same. We can also have n tuples. And the way we make a notation to say we've got a ordered pair is you say A cross B. So A cross B, this means it's an ordered pair where the little a is in the set capital A and the little b is in the set capital B. And you can have n tuples with lots of different sets. Okay, so let's go find the A cross B elements. So that would mean 1 from the set A and this 2 from the set B. I could also have 1 from the set A and 3 from the set B. And I could have 2, this 2 from the set A and this 2 from the set B, or the set 2 from A and 3. So there's 4 elements in this set of A cross B. Now I'm going to find the sets of subsets. So the power set of A cross B. So since there's 4 elements here, this is going to have 2 to the 4th elements. So let's do them. So you're going to have the set. So let me make that a little neater. So you're going to have the set that contains the 1 ordered pair 1, 2. And I'm going to have the set that contains the 1 ordered pair 1, 3. I'm going to go through all of these individually, right? So you have to make sure you start talking about the set. Okay, and then we know we have the null set, right? Okay, so now we're going to have the subsets that contain 2 elements. So I'll have the set that contains 1, 2, comma, 1, 3, and the set notation. Set that contains 1, 2, and comma, 2, 2. Oops, set notation, comma, and then I'm going to have the set that contains the 1, 2, comma, 2, 3, comma, and then, so there's still more to go, and then I'll have all the combinations of 3 of them, and then all 4 of them is the last one. So I'm not going to write all 16 of them out. Just want to make sure you understood what the sets look like that are in the power set of A cross B. This is very different. So we've got the power set of A right here, right? So if I was to write out what the elements of the power set of B are, they would be the set 2, the set 3, the set 2, 3, and the null set. Okay, so this is saying the x coordinate has to come from the power set of A. So that means these elements would be, I'd have the x coordinate be the set 1, comma, and then I'd have the combination or the different choices for the power set of B for the y. So I'll just do this one too. So it's an ordered pair that has sets as the x and y coordinate, comma. Okay, so what other elements would be in here? So I would have the set, the ordered pair that contains the set 1, comma, and then I'm going to move over here to pick up the set 3. So that's another ordered pair. So I'm listing all of the different options. So I'm going to have the set 1, comma, and the set 2, 3 in that ordered pair. Okay, so how many elements is this set going to have? Well, I've got 4 choices for the first coordinate, and I've got 4 choices for the second. So this is a different way of computing. We'll get 16 choices. And I'm not going to write them all down. Okay, so last question here. So find the power set of the null set. So what kind of subsets can I make with the null set? The null set, that's it.